All right, so with the formalities of installation, the console, and the scripting window now out of the way, we can actually start to focus on how you actually code using this language called R. Though I think it's perhaps worth pointing out to kind of the novice programmers in the audience that, nothing I'm going to discuss here is stuff you need to go out of your way to try and memorize. The thing to remember is that R is a language, and just simply the basic act of trying to use this language consistently will result in a kind of effortless memorization over time. That being said, there are some basic recommendations that I think it's helpful for novice programmers to follow. So, firstly, I would recommend don't use your computer's copy and paste functions. Type all of the code yourself. Secondly, try and replicate the results that I get by running the code on your own computer. That is to say, don't just watch what I do what I do. And lastly, from this point forward, you should really just pledge to do all of your statistics using R. That is to say, try and literally immerse yourself in this language because that's really going to be the fastest way to learn it. As we move through these videos, you'll learn more kind of advanced things, and a lot of this material will end up getting repeated and re-explained. So your goal at the outset here is not to become some R expert. Rather, it's more to just try and get an intuitive grasp of R's underlying syntax and logic. So what I think we should do first is fire up RStudio, but you could do all of this in the base R environment as well. So we'll grab a new R script here. Now, at its core, R is really nothing more than a fancy calculator, and we can basically use it as such. So you can use R to add, subtract, multiply, divide. It'll do all of that really easily. So let's maybe just demonstrate this. So if you type 1 plus 1, move to a new line, then we'll type something like 2 minus 2 maybe. Then we'll do like 3 times 3, and how about 4 divided by 4. So if we highlight all of that and we run it, you can see 1 plus 1 is 2, 2 minus 2 is 0, 3 times 3 is 9, and 4 divided by 4 is, of course, 1. We can also make use of exponents. So the way you use exponents is by utilizing the caret symbol. So if you hold down Shift on your keyboard and press the number 6, that should generate a caret. So for instance, if you want to write 5 to the power of 3, you just write 5 caret 3, and then when you run that line, you can see you get 125. Now there is an alternative way of doing this. So another way you could do this is by writing 5 double asterisk 3, and that works too. R will also follow the order of operations when kind of dealing with more complex expressions. So to illustrate, consider this expression. Suppose you have 8 divided by 2 multiplied by parentheses 2 plus 2. So a lot of people looking at this expression kind of mistakenly believe that it's equal to 1. Other people will say it's equal to 4, but in actual fact, it's equal to 16. So you can see R shows that it's equal to 16 here. So as many of you will no doubt have learned in kind of your primary education, according to the order of operations, so BEDMAS, brackets, exponents, division, multiplication, addition, and subtraction, or PEDMAS, if you're perhaps American, the order in which you divide and multiply inside a math expression is not fixed, right? Sometimes you divide first, and sometimes you have to multiply first. Most people understand this. However, what a lot of people don't realize is the order that you multiply and you divide in is not actually up to you. So you always need to make sure that you calculate from left to right. That's what determines the order that you multiply and divide in. And the same goes for addition and subtraction. So in this case, we actually have to divide 8 by 2 first and then multiply by 4. And just to actually prove that R is following the order of operations, we can we can actually rewrite this equation and see a kind of corresponding change in its output. So if we type something like 8 divided by 2, actually 8 divided by parentheses 2 plus 2, and then we multiply that by 2, what you should get is 4. So if we run this, you can see it outputs 4. I'm just going to clear the console there. So I just pressed Control L in case you're curious. Now, suppose you need to divide and you run into a situation where numbers aren't able to be divided evenly. So for instance, let's suppose you have like 11 divided by 2. Okay. When you run this, right, you can see R straightforwardly spits out a value of 5.5. So it gives you a value with a decimal point. And 99% of the time, this is exactly the kind of result that you're gonna want to see. However, sometimes, you might get a bit nostalgic for like elementary school, and you might want to see that kind of classic quotient and remainder style of answer. And R can do that pretty easily. So to obtain the quotient, what you do is you would say 11, and then you would say percent, percent, and in between the 2% signs, you just put a forward slash, and then you would put 2. So if you run this, you can see you get 5. So that's the quotient, and to get the remainder, basically you type the exact same thing. So 11%, 2, you just don't include the forward slash, and that will give you the remainder. So basically 11 divided by 2 is 5 with a remainder of 1. Or we could say something like 11 can be split into 2 groups of 5 with 1 left over. Admittedly, you're probably not going to use this form of division all that often, but it's good to know it's there, if you do need it, because there are situations where it does happen. Now, given that we're on the topic of just kind of basic arithmetic here, it's perhaps worth considering what happens when you kind of break the rules of arithmetic, so to speak. So suppose we divide a positive and a negative value by 0. What's going to happen when we do that? So let's say 1 divided by 0, and I like to put spaces on either side of the division here. And we'll also say negative 1 divided by 0. So what happens when we run these two lines here? You can see we get INF and negative INF. So this is just an abbreviated way of referring to infinity in the positive and the negative directions, respectively. Now, what happens if you take the square root of a negative number, let's say? So what if we type something like negative 4 to the power of 1/2? So if we run that, you can see R spits out this strange string NaN. So this stands for not a number, and it's a fairly sensible output given that the square root of a negative number doesn't exist as a real number unless you do something crazy like imagine it. So if you see like values going to negative or positive infinity, or you see not a number, that's usually a sign that there's something wrong. There's something wrong with the code you've typed, or there's something wrong with your data set, or who knows. Finally, since its use does crop up from time to time, it can be handy to know that R actually comes with the number pi stored as a constant. So if you simply type pi and you run it, R will display it to 7 digits. So you can see we get 3.141593. Now, if for some reason you find pi displayed to 7 digits here as being like inadequate for some reason, and you want to see more digits of pi, you can actually adjust R's settings by just running the following code. You would say options, and then you would say digits, and you would set this equal to 16. So if you run that, and then you go pi, you can see you now get pi to 16 digits. Now, technically, you can set digits here to be as high as 22, but displaying the number beyond 16 digits is actually going to be inaccurate because of just limitations of 64-bit computers. So anything after 16 digits is actually going to be complete gibberish and won't be accurate. It's also maybe worth pointing out, though, that even though R by default doesn't display all 16 digits of pi that it has stored, it's still using all of those digits in its calculations. So that's just something to keep in mind. Now, in the course of writing R code, there are going to be occasions where you would like to write, or you would like to run a script that you've typed up, but you don't necessarily want to run every single line on that script. There might be certain lines that you would at least, tentatively like to prevent running for one reason or another. And you can kind of accomplish this by simply commenting out a line of your code. So for instance, let's just look at these three. Actually, let's just look at these top 4 lines here. If you type a hashtag symbol, like so, any code that follows that hashtag symbol and is basically on the same line as it will not be run. So if we kind of select all 4 lines here and we run them, you'll notice this third line didn't actually run. It has no output. As another example, let's do this. As another example, suppose you had the expression 1 plus 2 plus 3 plus 4 plus 5. Okay, and let's suppose you put a hashtag right after the 3 and you run that. You'll notice it's giving us an output, but it's the output only corresponds to 1 plus 2 plus 3. It's ignoring the plus 4 and the plus 5. So this process is actually phrased as commenting out because the hashtag is also frequently employed to basically write helpful little comments to yourself and other readers about your R script. So the hashtag is a useful little tool you can employ in that regard. So yeah, that is where I think we will end this video, and we'll talk about some more stuff in later videos.